So we've been building to this point. We've been solving for x-intercepts, right? Why is it important to solve for those x-intercepts? They're really nice to draw for your parabola. They're really nice to draw for your parabola. Okay? Why? Because if you have the x-intercepts in the vertex, it's really easy to come up with the rest of the parabola. Okay? Or even if you have the x-intercepts in another point on the parabola, you can come up with the rest of the equation. Okay? So it makes it very easy to draw and easy to solve for the rest of the equation. Okay? So when a quadratic is written into a factored form, a lot of times it's written in y equals a bracket x minus r bracket x minus s and bracket. Okay? Factored forms means this times this times this, right? So what are the x-intercepts in this case? Positive r and positive s, right? Because if we set x minus r equals to 0, we'd add the r to the other side, we get x equals r. That's our x-intercept. As well as x minus s equals 0, add the s to the other side, we get s as our x-intercept. Okay? So we can solve for the x-intercepts using this formula. If the parabola has two x-intercepts, it has two factored things. If it has one x-intercept, a lot of times we see it as y is equal to a bracket x minus r all squared. Okay? What does that mean? It means x minus r, whatever that r value is, that's your one and only x-intercept. Okay? And if it's just x squared, guess what? Your x-intercept is at 0, 0. Okay? So if it can be factored and written in a factor form, it has x-intercepts. Okay? That last bell work you just did, it had one that didn't have an x-intercept. Right? That was my mistake. That last one did not have an x-intercept. It couldn't be factored. Okay? If you put it into your quadratic equation, you'd end up trying to take the square root of a negative number, and then you just say can't be done, right? Because as soon as you try to take the square root of a negative number, it cannot be done. So there are some quadratics out there that can't be factored, and those are the ones that do not have x-intercepts. Okay? So this form tells us lots of good things. It tells us the x-intercepts, x equals r and x equals s. It tells you the equation of the axis of symmetry, and I'm going to go over this equation with you. If you graph something, okay, and let's say this is 1, 2, 3, 4, 5, 6. Let's say I have a point at 5. Let's say these are our two x-intercepts. Sorry. If those are our two x-intercepts, I can solve for my axis of symmetry. Why? Because the axis of symmetry is right in the middle, right? And some of you guys have been helping you out with your problems. I said, draw it out and then count towards the middle. 1, 2, my axis of symmetry had to come along this axis. Why? Because everything is symmetrical with a parabola, right? And so now we're showing you a formula that you can use to come up with the axis of symmetry line instead of counting in like you're way back in grade school or something, right? So it's saying take the two values, 1 plus 5, add them together, divide by 2. 1 plus 5 is 6, divide by 2 is 3. Guess where your axis of symmetry line fell in? At 3, okay? So your axis of symmetry line, okay, and it's an equation, so equation means equal signs, right? Has to say x is equal to 3, well, in this case. Okay? Now, how do you come up with the y-intercept? The y-intercept is really easy to come up with because it's the last number, right? And so if you were to expand everything out, it would be the last number multiplied and added together, right? So that last number multiplied and added together is the value of a times the value of r times the value of s. Okay? So, depending on what it is, A times R times S is that y-intercept. And so, if I knew what this y-intercept was right here at 2 or 3, I could come up with another point on the parabola, right? By counting over 1, 2, 3 hits the the axis of symmetry. So I count over 1, 2, 3 more. So my parabola is going to look something like that. I still haven't found my vertex yet, right? But I could see that my parabola is coming in here and coming in here. Okay? This good stuff. Now, this just shows us, here's your axis of symmetry, R plus S divided by 2. Here's your point C. Look, if you count over 1, 2, 3, the parabola is at the same spot, 3 spots over away from the axis of symmetry. Okay? Same thing down here. When A is negative, it goes downwards, and A is positive, it goes upwards. We knew that already, right? So all we're learning is a couple new tricks today. Basically, what are we learning? We're learning how to find the axis of symmetry, R plus S, the x-intercepts added together divided by 2. And how do you find the y-intercept when it's in factored form? The x-intercepts times by themselves times by that big factored number out front, right? That big A value. Okay? So, what can we do with this? What can we do with this information? Well, they can say, can you sketch a graph of this? And yes, we have multitudes of ways of sketching this graph. We could plug it into our y equals in our graphing calculator and come up with an x and y table and graph it that way, right? We could factor it, okay, and graph it that way. You could put it into your vertex graphing form and factor it that way, okay? We're going to learn this factored x-intercept. So you have factored things before like this. This is what we've been doing the last couple days. What would you do first? Take out the common multiple of a 2, right? Have you guys seen this f of x before? Okay, f of x is just a fancy way of writing y. It really is just a fancy way of writing y. Okay, so the first thing we did was we took out the common factor of a 2. What should we do next? Is that a trinomial square? No, right? So then we got to do a general what times what? Well, multiply to give us 6 and add to give you 7. 6 and 1, right? So I can just generally write it as x plus 6 and x plus 1. If I FOILed that out, I'd get the x squared plus 7x plus 6. So it's going back to your factored roots. So now we have an equation that looks like this. Y is equal to a bracket x minus r times x minus s. Basically, right? It's in its factored form. What can we do with this factored form? Well, we can graph some stuff. Okay. Well, what do we know? We know x-intercepts. So I would write down what we know. Well, we know our x-intercepts. Our x-intercepts are -6 and -1. So -6, 0 and -1, 0. How did he come up with those? Right, so he took both of the factored forms, x plus 6, set it to 0. X plus 1, set it to 0, solved. Right? So that was one of the key things we could get out of here. The second key thing we could get is our y-intercept. What's our y-intercept? Well, remember y is equal to a times r times s, right? Or I shouldn't say y, c. C is equal to a times r times s. A is 2. 2 times, what's the r value? Is it positive 6 or is it negative 6? When we took it out, right, When we took it out here, we got x equals r and x equals s. When we took out here, we got x equals -6 and x is equal to -1, right? So the r value is actually -6 and the s value is -1, okay, or flip-flop. Okay, so it depends on what you take it out as. Okay, so it's -6 times -1. When we multiply that, 2 times -6 times -1, we get a positive value, right, of 12. So this gives us 12, so the y-intercept is 0, 12. Okay, this is great so far. We can graph 3 points on this parabola. Okay, and I'm going to graph 3 points on this parabola just quickly here. Okay, so -1, -2, -3, 4, 5, 6. So -1 and -6. And then the y-intercept is positive 12, right? 2, 4, 6, 8, 10, and 12. So this is great. I've got 3 points. Can I sketch out my parabola? We need our vertex. Okay, do we know any piece of our vertex? What else were we shown to do today? The axis of symmetry, that line of symmetry. So how do we come up with the line of symmetry? There's an equation. It's r plus s divided by 2, right? So x is equal to -6 plus -1 divided by 2. That gives you -7/2 is our axis of symmetry. That's what, -3.5 if you put it into decimals? Okay. So I'm just going to draw this in. -3.5. Oh. Okay, so not too bad. But does that give us our point? No, but it gives us something about our point of vertex. It gives us that the x part of the vertex is -3.5. Okay? So what can I do with that? Plug it into my original equation or to the equation that I factored, right? So I know that y is equal to 2 bracket x plus 6 times x plus 1. If I put -3.5 in, what do I solve for? I solve for a y value. What y value specifically? The y part of my vertex, right? So when I do this, let's plug -3.5 in. 2 times -3.5, sorry, plus 6 times -3.5 plus 1. When I do this, this gives me 2 times 2.5 times -2.5. -13.5. Good. At least someone can do math on a Monday morning for me. 12.75, 12.5. Okay. Is that better? Okay. Now, what does this mean? It means that our vertex is -3.5, comma, -12.5. Okay, so scroll all the way up, and we go down -2, -4, -6, -8, -10, -12. That vertex is down here, and then finally, we're actually able to draw our nice curvy parabola, like the question asked us in the beginning, okay? So, new things, kind of. Finding your x-intercepts, using them to graph. Finding your axis of symmetry, that's new, and finding the vertex using the axis of symmetry, that's brand new. Okay. I've got 2 more questions. I'm going to start one question today. We'll probably start tomorrow with a word problem question. I'll give you some time to work. The only thing for homework tonight is any late or old assignments that you've got going on in Unit 7 here. Okay? I'll get there, okay? Can you just let me... Now, do you think you could do something like this? Okay. I think you guys probably could do something like this. The big thing about this is you have to factor it first, right? Now this one says negative x squared plus 6x plus 10. So you either have to go through decomp, or my favorite cheater method to get out of decomp, when this is a negative 1, you just pull it out. So this will give me positive x squared minus 6x minus 10. Okay? Makes it easier because then you just have to think what times what will add to give me negative 10. No, multiply to give me negative 10 and add to give me negative 6. Oh, maybe that's hard. Can we factor this one? Oh, crap. I wonder if I typed in this question wrong or else, because I want to be able to come up with x-intercepts really easily. So I probably typed in this question wrong. So I'm just going to stop here. We have